Hi guys. Okay, so today we want to talk about exponential decay. Now before we get into some decay problems, let's make sure we're all on the same page, that we know the definition of an exponential function, the equation and what the variables mean, and then two terms that we want to make sure you're familiar with before we start some problems. So remember that an exponential function is in the form y equals y naught a to the t, where y is the amount that we have, y naught, that's y sub 0, is the initial amount, also known as the amount at time t equals 0. That's why it's y sub 0. That sub 0 is for time 0. T is our time, and A is our growth factor, or the decay factor, if we're decreasing. So if we're increasing, it's a growth factor, and that'll be a number that's bigger than 1. If our exponential is decreasing, that's a decay factor, and that number will be between 0 and 1. Okay, so next, we want to make sure you know two terms, and they're pretty self-explanatory. The doubling time of an exponentially increasing function, or an increasing quantity, is the time for it to double. So it has to be increasing if it's going to double because it's getting bigger. And similarly, the half-life of an exponentially decreasing quantity or function is the time for it to be reduced to half. So this time our graph would have to be decaying in order for it to be cut in half. Okay, so just some terms that you should know. Now let's take a look at our first exponential decay problem here. So here we have, in a department store, an item costs $325 and decreases by 20% per week. So we want to complete this table, and we know the price at the beginning is $325. Now, in order to fill in the price for each week, we would have to multiply by the growth factor, or in this case, it's going to be the decay factor. Now, here's the thing. If we're decreasing by 20%, that's the same as paying what part of the price? Well, the original price is 100%, and if we take off 20%, that leaves us with 80%. So decreasing by 20% is the same as paying 80% of the price. That means that our decay factor is 0.80, or just 0.8. So our A is 0.8. So we're going to multiply 325 by 0.8. We'll get 260. Then we're going to take 260 and multiply by 0.8, and we get 208. Now we take that, multiply by 0.8, we get 166, and remembering that this is money, we're going to round this to 0.40. So now we have the prices for the first 3 weeks. Next thing, write an equation to model this situation. Well, it's exponential, so it's y equals y naught a to the t or the x, whichever you prefer. We know that our initial price of the item was $325. And in part A, we discovered that our decay factor was 0.8. That means that our equation is going to be y equals 325 times 0.8 raised to the t. Now it's okay if you use an x. As a matter of fact, in the next part, we want to graph this. In order to graph it, if we're using the TI Inspire, it would be f1 of x. That means our independent variable is x. We cannot use a t. It would be 325 times 0.8 raised to the x. So let's see how that looks in our calculator. Okay, so here we are in our calculator, and we're going to graph our function. Instead of putting y equals, we have f1 of x equals 325 times our growth factor 0.8 raised to the, we cannot use the t, we have to use the x. Now when I hit enter, you'll notice I don't see anything. That's because we're not in a good viewing window. So let's go to our menu, window zoom and window settings. Now let's think about this. X is the time. We don't need negative time, so we're going to start with 0. X max. How many weeks do we think this is going to be in there? It's probably not going to be there for 100 weeks. Let's just take a random guess. I don't know, maybe 10 will work, maybe 20, let's say. We can always come back and change it. I'm going to let the scale stay as auto. Now the Y min, the Y is the price of the item. It's never going to have a negative price. And the most expensive is when it started at $325. So I'm going to pick a number a little bit bigger than that. Let's go with $350 just so we can see. Again, I'll leave it on auto. Click OK. There is my graph. And this is indeed exponential decay. So you can see how it goes down. The hardest part of graphing this is just checking the window. And guys, if we didn't have a big, if this didn't go far enough for 20, we could always go back and we can take our window settings and change and say, oh, I want to look all the way out to 50 weeks. And you can see that's way too far out, isn't it? So I'm going to change that 50 back to 20 because that really was a nice picture there. Okay, guys, let's go back to our document. Okay, so now we want to know what week will our item be half price. So half price means it would be 1/2 of the $325. So half of that is $162.50. So what do? We want our equation 325 times 0.8 raised to the x to be equal to $162.50. In order to do this, now remember in our calculator we already have 325 times 0.8 raised to the x. That's already in our first function. So in the second function, we're going to put the other side of the equation, $162.50. We're going to get a horizontal line, and we want to find that point of intersection. That'll tell us when our exponential function equals the half price. Okay, remember, anytime you have an equation, you can solve it by putting one side in f1 of x, put the other side in f2 of x. All right, let's go see what our calculator says. Okay, so if we want to find when the item will be half price, we already have our function in f1. I'm going to tab up. I'm going to put the half price, which is $162.50, into f2. We can see that the two graphs intersect. So if we want to find the point of intersection, we go to Menu, Analyze Graph, Intersection, go to the left for a lower bound, the right for an upper bound, and here we have our point of intersection. So that would be 3.11. Okay, so according to our calculator, the item will be half price at the week 3.11. Now here's the thing. Mathematically, this is our answer. In reality, our item is never going to be half price. At week 3, because the price only changes every week, at week 3, it's going to be slightly more than half price. And at week 4, it will be less than half price. Okay, because the price doesn't change at 3.11 weeks. It only changes at 3 weeks and then again at 4 weeks. All right, so if you want it half price or less, you've got to wait till the 4th week. Okay, let's take a look at another problem. So Mr. Embezzle is gradually withdrawing money from his grandmother's safe, which originally held $40,000. So at the beginning, the safe held $40,000. He takes out 10% of the balance each month, and no other money is added or withdrawn. Now remember, there was 100% of the money in the safe. If he takes out 10%, what's left? That's 90%. So taking out 10% is the same as having 90% of the balance. Okay, that's going to mean that our decay factor, so 90% is a decimal, is 0.90. Let's complete the table showing the amount in the safe each month for the first 6 months. So in order to do this, we're going to multiply by our decay factor, A, which is 0.9. So 40,000 times 0.9, that's going to give us $36,000. Now we multiply that by 0.9. We have $32,400. We multiply by 0.9 again. We'll get $29,160. Now we're going to multiply by 0.9 again, $26,244. And remember, this is money, so we're going to round to the nearest hundredth, 2 digits after the decimal whenever we need to. Oh, and look at that. I already pressed times 0.9, and now I've got $23,619.60. And if I multiply this one more time times 0.9, I will get $21,257.64. So he's going through his grandmother's money like crazy. Not a nice thing to do, by the way. Okay, let's write the exponential equation that can be used to calculate directly the amount remaining in any month. So the initial amount that was in the safe was $40,000. And we said that the decay factor was 0.9. So an exponential equation, y equals y naught a to the t, becomes y equals 40,000 times 0.9 raised to the t or the x. You know what? I'm going to use x this time, just to be different. Okay? Now, in how many months will the account lose half its value? So half its value, half of 40,000 is 20,000. So we want to know how many months until we get to there's only $20,000 in the safe. Well, we have our equation 40,000 times 0.9 raised to the x, and we want that to be equal to 20,000. So whenever we have something like this, we're going to put one side of the equation in f1 of x, and we're going to put the other side of the equation in f2 of x, and we're going to find the point of intersection. Okay, so let's take a moment and find that point of intersection in our calculator. So let's see, we need to tab up to our window. We put the left-hand side, 40,000 times 0.9 raised to the x in one side, in f1 of x. Then the other side of the equation, which is 20,000, into f2. And notice I don't see my graphs. We need to fix our window. So we go to Menu, Window Zoom, Window Settings. So the x's are the time. We don't need negative time. Now for this, take a guess. Do you think it's going to be in your lifetime or not in your lifetime? So this is usually what I tell my kids. If you think it's in your lifetime, go with 50. If you don't think so, go with 100 and then change from there. So I'm going to go with 50. And then my Wyman, the amount of money, we're not going to have negative money in a safe. And the most money that was in the safe was $40,000. So let's say we'll go to $45,000 just so we have a good view of it. And we hit OK. And there are our two graphs. Okay, so we have our two graphs and we see that they intersect right here. Last time we did one, we did it by analyze graph. So this time I'll do menu, geometry, points and lines, intersection point. Click on the first graph, click on the second graph. There's your point of intersection at 6.58. Okay, so our calculator told us 6.5788 months. Now we would probably tell you to round that to the nearest tenth or hundredth, so it would be 6.6 months or 6.58 months. But we'll tell you what we want you to round to. Now we're going to use our equation to compute the amount in the account at the end of 20 months. So 20 months, that's our time X, which we called it this time. So 20 months here. And we're going to plug that in. Y equals 40,000 times 0.9 raised to the 20. Now let's go to our calculator and put that in. Okay, the last part here, we want to figure out how much we have after 20 months. So we type in 40,000 times 0.9 raised to the 20 and hit enter. And there it is, $4,863.07. All right, awesome. In 20 months, which is less than 2 years, Grandma only has $4,863.07. Wow. He went through $35,000 in less than 2 years, stealing from Grandma. Okay, guys, so there we have it, our exponential decay, and we'll see you in class soon. Bye, guys.